Chapter 26 review, and let's finish this up, numbers 20 to 24. So to determine the planting time, okay, so we wanted to see if they were related. So that to me is implying independence, okay? So with that, if there's a relationship, so I'm doing a chi-squared test of independence. So furthermore, when I would do my conditions, I would probably do them actually, and this is kind of annoying, on summer, fall, winter, and spring, because I would intend on the planting time to be the driver to the results of the blooming, okay, in spring. So when you plant those bulbs, affects how well they bloom, or we're seeing if that does. All right, so let's see. It says, yay, only provide the hypothesis statement, name a test statistic, and conclusion. So meaning you don't have to do the conditions, sweet. So here we go. The null hypothesis is the bloom results and is independent of planting time, and the alternative bloom results are not independent. Don't have to do the assumptions, so that's great. Chi-squared test of independence, and when I put that into my calculator, those are the results that I get. And since this 0.0183 is less than an alpha of 0.05, I reject. Since the p-value is less than alpha, I reject that the planting time of the bulbs is independent of bloom activity. Now, I didn't think any of these problems had done this, and so I wanted to do one of these so that you could remember how to do this in case you see this. If you were asked to give further information as to what maybe contributed most to your rejection, don't forget that the way to handle that is by doing the standardized residuals. Okay, standardized residuals. Standardized residuals is coming from the unsquared chi-squared test statistic. So basically take this such that it's not squared. Squaring it makes it all positive. If you have that unsquared where you're just doing observed minus expected over the square root of expected, then you get a sign, a direction, a positive or a negative to tell if it's above or below. Now, I can see that I did this and it's kind of tricky. I'm thinking, how did I do that if I don't even have written here the expected? I would have had to come up with the expected matrix and listed that here. Okay, so for all the things and for blooming and not blooming and so on. So I would have come up with that and done an observed minus expected over the square root of expected for each one of those spots. All right, 21. We have a geneticist that claims that these 4 species of fruit flies should appear in this ratio. You need to know how to handle a ratio such as this. If this says the ratio is 1 to 3 to 3 to 9, you need to understand that that means it is a total of 16 items. So therefore, the first ratio is 1/16 to 3/16 to 3/16 to 9/16. So those are the expected percentages. So when I have 4,000 is my total size, so then I can say that my observed are these ones: 226, 764, 733, and the 2277. And then to get the expected, what I'm having to do is say, for the first one, 1/16 of the 4,000. That's how I'm getting that expected. And the next one is 3/16 of the 4,000, and so on. Okay, 3/16 of the 4,000, and then this one is the 9/16 of the 4,000. All right, so that's how I'm getting those values. And I believe that I have it written here. Okay, very good. So I have that written here in this table. Show the observed and the expected lists, not the matrix. So that's interesting that that has matrix written there. I guess you can kind of think that that looks like a matrix. Run a test and determine the answers below. So we put those into list 1 and list 2. Run the chi-squared goodness of fit test. And you get a chi-squared of 3.28, p-value of 0.351, which is plenty big, such that you would fail to reject. So first of all, never say proves the geneticist claim. The test does not give sufficient evidence to reject the geneticist claim is the correct way to say that. Of course, if you rejected it, D would be the best way to say that. Test is inconclusive. I guess that would happen if you had maybe conditions that wouldn't work, but otherwise our numbers do say one way or the other. All right, 22 is our men and women for and against, and we're wondering if gender is affecting that. We do a chi-squared test for that really quickly, and we get a chi-squared value of 2.0708. And then B is asking you to do a 2 proportion z-test. So I went and put these into the calculator for a 2 proportion z-test. And when I did that, I got a z-score of 1.439. So I ran a 2 proportion z-test. And the relationship between this z-score is that if I square it, it is the same value as the chi-squared when you ran a chi-squared test. So that will actually happen whenever you have a 2 by 2 matrix, because a 2 by 2 matrix can also be shown as can be written as a 2 proportion test. All right, number 23. Let's see how that one's going to go. All right, we got the observed. This is a goodness of fit as well. We have the observed. They give us the expected percentages. So the expected percentages is for Democrats is 40% of the total 200. Republicans and so on is 40% of the total 200, and others 20% of the total 200. So there's my whole phantoms with the hypothesis statement. It actually says I don't have to do the assumptions. Current rate of party representatives by registered voters matches the rate, so does not match. Goodness of fit test, chi-squared I ran. I put them in list 1 and list 2 and ran a chi-squared goodness of fit. Chi-squared of 4.6, p-value 0.1003 with a degrees of freedom 2. And that came from 3 categories minus 1. 3 categories were the Democrat, Republican, and other. So that p-value is greater than alpha, so I fail to reject. I do not have evidence that the rate of party representation has changed. And our last one, number 24. Basically, you need to run yourself a test on that. 70 is the total. N is the 70. Okay. Run a chi-squared goodness of fit test because you had 29 observed tails, which meant 41 of them were heads, so that totaled 70. Expected, see, if it was fair, then you would have 50% heads and 50% tails. So that would mean half of 70, which is 35, for the heads, and half of 70 for the tails, which is also 35. All right, so I ran that test, chi-squared goodness of fit. Got a 2.06 with a p-value large enough to fail to reject. Chi-squared at 2.06 did not reject at the 0.05 significance level. This, again, significance level is indicating your alpha is your 0.05. And that is it. So good luck on your test tomorrow.